last part we have seen the combined mean and example on it. In this part we are going to discuss about the variability. Let us consider two groups. The performance test was administered to both the groups and the data are obtained as given in this. Uh, Now consider first group. If we count these scores, then number of scores n is equal to 10. And if we find the sum of all the scores in group 1 is 225. Sorry, 250. So its mean is equal to 25. Now let us consider second group. Again we count the number of scores in second group. Then n is equal to 10. And if we find sum of all the scores in second group, then sigma x is equal to 250. So its mean is also 25. That means these are the two groups of individuals whose means are same. Can we say that these two groups are same or identical? And answer is no, because there are a lot of differences between these two groups. Now we consider first group. The highest score is equal to 48 and lowest score is 3. Now if we find the range of first group, range is equal to highest score minus lowest score. That means 48 minus 3, which is equal to 45. That means the range of first group is 45. Now let us consider second group. In second group, highest score is 35 and lowest score is 70. So its range is 35 minus 17 and which is equal to 18. That means the range of both the groups is not same. Their means are same but range are different. For first group range is 45 and for second group range is 18. That means there are lot of difference between range. In first group these scores are distributed from 3 to 48 and in second group these scores to 35. That means the range is different. Now this shows that the groups are not equal even, their means are same. If we consider second group, then for second group mean is 25 and the range is 18. Almost all, or we can say that majority of scores are near about the mean. But in case of first group, mean is 25 and range is 45. Some scores are near about mean, but others are away from mean to extreme points. So we can say that in first groups there are the individuals whose are poor in performance, some are average in performance and some are higher or good in performance. While in second group, majority of or near about all these scores are around the mean. That means these scores do not show the individual differences among these individuals, even among the group second. So we can say that the first group is heterogeneous while second group is homogeneous. That means their means are same, but the distribution of scores in a group is different. So such a type of tendency of scores in a distribution in a group is called variability. So we can define variability is a tendency of attribute of a group to deviate from the mean or center of the score series. Is now the degree of variability can be measured with the help of four measures. These are called measures of variability. One is range, second is average deviation, third is quartile deviation, and fourth is standard deviation. Now we will consider the first measure of central tendency, range. Actually here we have used the concept of range. That means difference between highest score and lowest score is nothing but the range. For the first group range is 45 and for the second group range is 18. Now we consider the second measure of variability as average deviation. Average deviation is also called mean deviation. Average deviation is the mean of the deviation of all scores taken from the mean of the group. Now let us consider the example. Calculate the average deviation of following data. Data is given. Now we have to find the average deviation. So firstly we have to calculate the mean of given data. So we count the scores. If we count these scores, then these are 10 in numbers. That means n is equal to 10. And their sum is sum of all scores x is equal to 380. So its mean is equal to 38. Now we take the deviation of each score from the mean. So take a deviation. So we can denote the deviation as small d. Now small d is as 30 minus 38. So 30 minus 38 is minus 8. 35 minus 38 is minus 3. Then minus 2 plus 1. Then plus 5. Again plus 6. Then for 46 deviation is 8. For 38 deviation is 0 because 38 minus 38 0. Then 34 minus 38 is minus 4 and 35 minus 38 means minus 3. Now take the absolute value of these deviations. That means mod of d. So mod of d is equal to 8, 3, 2, 1, 5, 6, 8, 0, 4 and 3. Now average deviation or mean deviation is the mean of deviations of scores. That means mean of this mod d. So take summation of mod d. If we take summation of mod d, then it will be 40 and n is equal to 10. So average deviation or mean deviation is denoted by AD. So AD is equal to 40 upon 10. So which is equal to 4. That means average deviation of given data is 4. Now we calculate the average deviation of frequency distribution. Let us consider the example. Calculate the mean deviation of following distribution. These are the class intervals and their frequencies are given. Now for calculating mean deviation, we have to firstly calculate the mean of the distribution. So we will find the midpoint of the distribution class intervals. So midpoint, we denote this midpoint as xm. Now for first class interval, midpoint is 82, then 87, 92, 97, 102, 107 and 112. These are the midpoints. Now we find the sum of all the frequencies, that means number of scores. If we take the sum, then n is 18. Now for calculating mean, now we find the product f into xm, that means frequency multiplied by midpoint. So f into xm, for first interval it is 328, then 348, then 276, 0, 306, 321 and 112. Now find the sum of all the products. So summation f into xm is equal to 1691. Now firstly we find the mean of the distribution. So mean is equal to summation f into xm upon n, and which is equal to 1691 divided by 18, and the mean is 93.94. 93.94. Now we have to calculate the deviations. Deviations, that means these are the scores, and we have to calculate the deviation from mean, but we take here midpoints, so we have to take the deviation of the scores, means from of the midpoint from mean, that means xm minus mean. So take deviation, d is equal to xm minus mean. Now we can calculate the deviation. The deviation of first class interval is minus 11.94, then for second minus 6.94, minus 1.94, then plus 3.06, 8.06, 13.06 and 18.06. Now we take absolute value of these deviations. So for first it is 11.94, then 6.94, 1.94, 3.06, then 8.06, 13.06 and 18.06. Now calculate the product f into mod t, that means frequency multiplied by the absolute value of deviation. So for first interval it is 47.76, for second interval it is 27.76, for third interval it is 5.82, for next interval it is 0, then 24.18, 39.18 and 18.06. Now take sum of these products, that means sum of f into mod t. So sum of f into mod d is equal to 162.76. So we can find mean deviation or average deviation as mean deviation MD is equal to summation f into mod d upon n. That means which is equal to 162.76 upon n is equal to 18. So divided by 18 and which is equal to 9.04. That means the mean deviation of given distribution is 9.04. For calculating mean deviation, firstly we find mean by midpoint method and then take a deviation of midpoint from the mean and find their absolute values and product of frequency into absolute value and calculate mean deviation by this formula. We get mean deviation is equal to 9.04. Thus, in this part we have seen the definition of variability and two measures of variability, range and mean deviation. In next part we will consider the third measure of variability, quartile deviation.